Okay, part C, using and applying combined variation. Okay, part C is where we're pulling it all together. So here, the steps to solve. One, we use the given information to write one of the combined variation equations. So if you look over here, these are our combined variation equations. If it says that Z varies jointly, that means that everything is being multiplied. You're finding the product of it. Okay. If it says that it varies jointly with two of them and inversely with another, that means I am multiplying and dividing. And then the same thing here, if it says Z varies directly with X and inversely with the product of WY. So key things to take away here is that jointly and direct are going to imply multiplication. And inversely implies division. That got really jumbled in there, but inversely implies division. Okay. Step 2 is to substitute all known values in to create a function to model the situation. Step 3 is we're going to use inverse operations to solve for the unknown. And then step 4, we're going to write this. I wrote write the wrong way. We're going to write the solution how it pertains to the problem. Ready, Freddies? Okay. So as seen, this would be a potential SAT problem, ACT problem, any math placement exam problem, potentially. So the number of bags of grass seed in needed to reseed a yard varies directly with the area to be seeded and inversely with the weight W of a bag of seed. If it takes 3-pound bags to seed an area of 3,600 square feet, how many 3-pound bags will seed 9,000 square feet? Okay, so we're going to adhere to the words that are being utilized. So remember, directly means that we are multiplying. And inversely means that we are dividing. So we have N needed. So N equals, and everything has a constant. So whether our constant, that's K, has to be there. And it varies directly with area, which is our A. So K times A. And it inversely with the weight W. So that means I'm dividing W. So we have N equals K times A divided by W. So that's our step 1. Step 2 is to use the given information to solve for our K. So based on what we read here, it says if it takes 2 3-pound bags, so we know the number of bags is 2. We know that the weight of the bag is 3. And we know the area that it's covering is 3,600. Do I have enough to solve for my K? I do. So we have 2 equals K times 3,600 divided by 3. Multiply both sides by 3. And that gives us 6 equals K times 3,600. And then we're going to divide both sides by 3,600. And that leaves us with K equals 1 over 600. So now we're gonna step 3, we write our function model. So our function model is n equals k times a. So our k is 1/600 times a over w. Can I clean this up? Yes. So n equals a over 600 w. So 4 is answering the problem. And so it says, how many 3-pound bags will seed 900 square feet? So it tells me here, my W equals 3, my A equals 9,000, and it wants to know what is in the number of bags. I have something, so I have N equals, A is 9,000 over 600, and W is 3. So that gives me 9,000 divided by 1,800. Divide each by 100. That leaves me with 90 divided by 18. And what is 90 divided by 18? 5. So my answer would be 5 bags.
I'm pretty sure this one wasn't our problem, but if you divide 600 divided by 2 and then divide the and divide 9,000 by that answer, you don't get 5.
3,600 divided by 2.
Divide that by 2, and I'll get you 1,800 and divide 1,000 divided by 1,800 will be 5.
Probably. In this case, yes. So the answer for this problem would be 5 bags. All right, so step 1 again, you create the compound variation. Step 2 is use given information to solve for your constant. Step 3, create your function specifically for this problem. And step 4 is to apply it to solve and answer the question. All right, we're gonna do another one. So it says here, the number of bags of mulch you need to cover a planting area varies jointly with the area to be mulched, A, in square feet, and the depth of the mulch, D, in feet. If you need 10 bags to mulch 120 square feet to a depth of 3 inches, how many bags do you need to mulch 200 square feet to a depth of 4 inches? So step 1. Good job. And why did you say that? Varies jointly. So the key thing here, it says varies jointly. So that means that everything is being multiplied. Okay. And the number of bags. So even though it didn't tell us a variable for number of bags, we can just make that in ourselves. Does that make sense? So step 1, we know that N equals, and there's always a K, and it varies jointly with the area, which is A, and with the depth of mulch, which is D. So K times A times D. That is our combined variation that we're using. Step 2 is to use the information that's given. So it tells us if you need 10 bags, so I know N equals 10, to mulch 120 square feet. So A equals 120 square feet to a depth of 3 inches, and D equals 3 inches. And we can use this to solve for our K. The thing here is, what do you notice about A and D? They're 2 different units, right? So before I can do anything, they need to be the same units, okay? And it's easier to go from inches to feet in this case, right? 3 inches is in what relationship to a foot? It's a fourth, 1/4, exactly. So this is 1/4 of a foot. Does that make sense? So now my units are the same. So I can proceed to solve for K. So I plug in everything. So I have 10 equals K times 120 times 1/4. So I have 10 equals K times 30. Divide by 30. So K equals 1/3. Still good? So step 3 is to write our function for this problem. So we know N equals 1/3 times A times D, or A times D divided by 3. So now in 4, we can answer the problem. So 4 is saying, how many bags do you need to mulch 200 square feet in a depth of 4 inches? So we know that our A equals 200 square feet, and we know that our D equals 4 inches, which is 1/3 of a foot. So I now have all the information. So N equals 1/3 times 200 times 1/3, which equals 200 over 9. 9 goes into 20 2 times with 2 left over. 9 goes into 20 2 times with 2 left over. So we end up with 22 2/9. So the number of bags needed, it's actually, can you buy 2/9 of a bag? No. So the answer would be 23 bags in order to guarantee you cover everything. Because I went over 22. Does that make sense? And we round up because this is a real world situation. You're not going to under mulch your yard. All right, how do we feel? Still doable? Cool. All right, I'm gonna bring a little physics into your life. Boom. So gravitational potential energy, PE, is measure of energy which varies directly with an object's mass m and its height in meters, okay, above the ground. Physicists use G to represent gravity, which is the constant of variation, okay? If G equals 9 8/10, how much potential energy would a 41 kilogram diver have standing on a 10-meter diving platform? Okay, so reading all of this, we have PE, varies directly. And what does directly tell us again? Multiply. With an object's mass m and its height h. So PE equals our constant times m times h. Okay, so that's step 1. Step 2 is to find our K value. Well, they tell us our K value. They said our constant of variation is gravity. So we already know that K equals G, which equals 9 8/10. Do we see that? Because they told us our constant. So step 3, our equation that we have here is potential energy equals 9.8 times the mass times the height. And now we can solve the problem. So our given information is 41 kilograms. That's my mass. And then my height is 10. So to find my potential energy, it equals 9.8 times 41 times 10. So potential energy equals, which equals what? 4,018. And we call these joules. Joules. That's the unit that is created by multiplying the mass times gravity times the height. All right, and that concludes it.